is a projectiles question from one of the CCEA A2 Applied Maths past papers. This one's from 2019 in June, and this is question 4. So a footballer taking a free kick strikes a ball and it leaves the horizontal ground with speed u at an angle of alpha to the horizontal. The ball is projected from 0 as shown in figure 2 below and is modelled as a particle. The ball remains in the same vertical plane and experiences no air resistance. Show that the equation of trajectory for the ball is y equals this, where x and y are the horizontal and vertical displacements of the ball from 0. A fairly classic question, and obviously kind of something that's on our course that we need to be able to work out. So as with all the projectile things, we're going to take vertical motion and horizontal motion separately. So we're going to have u, v, a, s, and t, and u in this case we're not going to cross that, so it's u sine alpha. Again, you should be well used to that doing any projectiles questions. So that's u sine alpha. V we're not worrying about. A, my upwards is positive, so it's going to be a minus g. S is the y. It's the horizontal displacement, so the vertical displacement then is going to be y. And then the t, we're just linked to be a capital T. So we're going to substitute this in. S equals ut plus a half of a t squared. So y equals u sine alpha upon t. So it's going to be ut sine alpha minus g then instead of a. So minus g over 2 t squared. So that's us up and running. Horizontally, we're going to have s, which is obviously in this case then the x. That's our horizontal distance at any particular time. Our u, again back up to here and resolving this way. Again, you should be well used to this with u cos alpha. And then our time again is going to be t. Effectively, we're going to get an equation here for t and substitute it into this, and this gives us this up here eventually. So this is just speed, distance and time if you want, or if you want kind of a different way around. So time then is going to be distance over speed. You can use the s equals ut plus half I t squared there as well if you wish. There's just no acceleration in this scenario, so that bit all disappears, and then so a displacement is in distance times speed times time, and I just kind of rearrange it then from there. So we're gonna call this 1 and 2, and effectively we're going to substitute 2 into 1. So let's take it nice and slowly here on our next page, and we'll see how we get on. So our equation number 1 is y equals ut sine alpha minus g over 2 t squared, and substituting that in, we're going to get y equals u upon x over so that's not a t2, that's a t squared, of course. So I hope that makes sense just about. So what did we do? We obviously had this, and anytime we see a t, we've exchanged it then for this. Now to tidy things up a bit. There's a u here on the top and a u on the bottom, and they're going to cancel out. That's also a sine alpha over a cos alpha, so that just changes into a tan alpha, and the x is left, so it's x tan alpha. Tidying this up, that's an x squared on the top, so it's gx squared on the top, and then a u squared cos squared alpha on the bottom, then times by the 2. So I'm going to tidy that up slightly. So gx squared all over 2 u squared, and then inside the brackets what I haven't taken out is cos squared alpha. That gives me y equals x tan alpha minus gx squared over 2u squared. 1 over cos squared is obviously sec squared alpha. And we know from our trig and our pure that sec squared is 1 plus tan squared. And that's effectively our last line. And that's what we've been asked then to prove. I assume in the next part then we'll have to use that. Ball is kicked towards a stationary teammate who is 15 metres from O and on the same horizontal level. The initial speed of the ball is 14, hence find the possible angles of projection for the ball to land at the foot of the other player. So we're effectively trying to find alpha, and it says angles there, so it's maybe going to be a quadratic or something we're going to have to solve. So we know that it was projected at 14, so that means our U then is 14. Projected stationary on the same horizontal speed to find the possible angles of projection. Then our y is going to be 0 because it's coming back down to the same point. Remember, it goes like that and back down. So what's the change in the height? There's no change in the height, it's just 0. And then x then is 15. So if I go back then to my equation, let's see if I can get both of these on the screen so you can kind of see at least what I'm trying to substitute in. You can just about see that there. Maybe not the best way of doing this, but that's okay. We are going to have y is 0, so 0 is equal to 15 tan alpha minus g, so the x squared then is 15 squared all over 2u squared, so that's 2 upon 14 squared 1 plus tan squared alpha. So some kind of crazy numbers here to work out. So let's see what I have. 15 tan alpha, and then we have, this is kind of quite messy here, but with 225, see if we can tidy this up a bit. So 15 squared is 225. 225 times 9.8 is equal to, divided by 2 equals divided by 196 equals, so that gives me then kind of 45 over 8. So I'm then going to do a bit of tidying up. So I'm going to kind of times through by 8, but also cancel then by the 15. So I'm dividing through everything then by 15. So I have a 1 and a 3 and times then by 8. So my 0 is going to be 8 tan alpha minus 3 1 plus tan squared alpha. And now I have a quadratic. So that's a minus there. So I'm going to take everything over to the other side. So I'm multiplying through it by 3. So minus 3 minus tan squared alpha. Taking everything over to this side is going to give me 3 tan squared alpha minus 8 tan alpha plus 3 equals 0. I'm going to solve that quadratic. So you can put it into the formula, whatever way you want to do it. And again, I'm not going to do that for us at the minute. If you want and you're uncomfortable with that, if you wanted, you could pick a letter, you know, p equals tan alpha, and you have 3p squared minus 8p plus 3, and you can kind of work it out like that. But either way, tan alpha is 2.215, or tan alpha is 0.4514. And if you do then kind of shift tan, or tan to minus 1, you get 65.7 degrees or 24.3 degrees. And those are the two possible angles of projection that we've been asked for.